Kia ora. Here's our third example. So hopefully you go straight to the molecular ion in the mass spectra, and you see that the M plus ion is 87, which is an odd number, so there are odd number of nitrogen atoms present. We know also from the IR that this is correct because we have a distinctive peak for a secondary amine, or it could be an amide as well. So it's a NH, so a nitrogen bonded also to a carbon. And we see, okay, that could be an NH-WAG, but we see here very clearly two peaks in this area where we expect the carbon to be bonded to a nitrogen. And because it's two, we can see it'll be a secondary amine with a nitrogen bonded to one carbon, which is this one, and to another carbon, which is that one. So secondary amine, it is not an amide because we don't have the carbonyl. So we know there's no chlorine or bromine because there is no distinctive pattern. Make sure you explain that pattern, that isotopic pattern, 2 units apart. And then supported by, there's no real sharp absorption peaks here for an RX. So there's not that much we can say. We can say alkyl. Remember, you can always cross-link the alkyl from the NMR just downfield or just slightly above the 3000 peak or towards the right. And we have these very upfield peaks that tend to be always alkyls in the NMR. We can clearly see there's no alkene in the NMR. It's very distinctive. And there's also nothing here in the IR. So we know alkenes are absent. And as I said, there's no carbonyl, and we can see that very clearly as well in the NMR. So all these functional groups are absent. Make sure you list them. So formula, we started with 87, subtract the value of 14, which is the molar mass of nitrogen, to get 73 for carbons and hydrogens, divide by 12 the molar mass of carbon, and we get 6. So 6 times 12 is 72, which gives us only 1 hydrogen, which doesn't make sense, not for 6 carbons. So I would drop down a carbon. We have 5, and therefore we now have 13 hydrogens. And this fits very much the saturation of the CnH2n plus 3 for a saturated nitrogen molecule. So all the best. Kia ora.